All right, Bobby, I'm a sixth grader. Yippee, integration. I need some help with this problem. All right, Bobby. Well, in sixth grade, man, congratulations. But let's give it a whirl. Integration. Haven't done this one in a very, very long time, not since I've been teaching calculus. So this should be a little fun. All right. So I need to integrate definite integral on the interval from 1 to 4. And I have the rational expression 5x plus 4 divided by x squared plus 2x dx. All right, so the first thing I'm going to want to do is break up this rational function using partial fraction decomposition. So what I'm going to do here is I'm going to take a 5x plus 4 divided by, I'm going to factor out this denominator here, because what I want to do is I want to take this rational function and I want to break it up into its parts. So I want to see how I can break that up, and x squared plus 2x, I could break that up into a x plus 2. And what you're thinking about with partial fraction decomposition is what two fractions would combine together to give you this. So it's kind of like that reverse operation here. So I don't know what the numerators would be, but I know if I was to add these two functions together, if I was had like a over x plus ab over x plus 2, right? If I had like two fractions, I had to get common denominators, which would be x times x plus 2. And then I need to be able to figure out what my a and b are going to be. So one way to be able to identify our a and our b would be to, first, we need to get rid of our denominators. So the first thing I'm going to do is I'm going to multiply everything times a x times x plus 2. When I do that, I'm now going to have a 5x plus 4 is equal to, so if I multiply that times that, those denominators divide out, x times x plus 2 over that, that's going to leave me with a times a x plus 2. And, oh, I did run out of space. So there you go. All right. And then x times x plus 2 over x plus 2, the x plus 2s are going to divide out. So that's going to leave me with a b times x. All right, so now we need to identify what our values for a and b are going to be. So one way we can go and do that is identify some values for x. So what I want to do is I want to find some values for x that would eliminate one of the variables, and then I can solve for the other. So for instance, what if I let x equal a negative 2? If x equals a negative 2 here, negative 2 plus 2 is going to be 0. 0 times a is going to be 0, and then I can just solve for b. So I'll say the first one, I'll be let x equal a negative 2. So then I plug that in. So we have a 5 times negative 2 plus 4 equals a times negative 2 plus 2 plus a b times a negative 2. That's going to be negative 10. Negative 10 plus 4 is going to be a negative 6. Negative 2 plus 2 is 0. 0 times a is just going to be 0. So therefore, that's going to be a negative 2b. Divide by negative 2. Divide by negative 2. B is equal to a 3. All right, so we got the first one out of the way. Let's do the next one. What about if I let x equal to 0? So if I say let x equal 0, now let's do the thing all over again. So I'll do a 5 times 0 plus 4 equals a times 0 plus 2, right? Yeah. Plus 2 plus a b times 0. That goes to 0. That's going to become 2. 0 plus 2 is 2. 2 times a is 2a. And 5 times 0 is 0. So I have a 4 equals a 2a. Divide by 2. Divide by 2. A is equal to a 2. Okay. So now I can break this up here. Now it's going to kind of work on actually doing the integration. So I can break this up into my partial fraction decomposition with a being 2 and b being a 3. So I can break it up like this. So now I can rewrite this as a is 2, right? So 2 over ax plus a, what was it, 3, 4 to 1, as a 3 over ax plus 2. Right? So since I have two separate now rational functions, I can now break it up, the integral, I can now break it up for each rational function from on there. Now, I also recognize I'm going to be dealing with taking the integral of a reciprocal function. So that means my 2 and 3 are both going to be scalar constants. So I can take them outside of the integral. So therefore I have a 2, let's put it as 1 to 4 over a 1 over x. And then over here, I can bring that up, but then also I can see that I'm going to use, again, some u substitution. I'm going to say let u equals a x plus 2. So yes, I am going to take the 3 on the outside out. But now what I'm going to do is I'm taking the integral of that. I'm going to have that as a 1 over a u. Okay? So now I just need to understand, because now these are in a very similar form, that if I want to take the integral of the reciprocal function, I know now that's going to be my natural logarithm in this case. So I am now, oops, I forgot to write my dx. Holy crap. Got to be mathematically sound. Right? Okay. So now let's go ahead and just take the integrate on both sides, and then we'll do the definite integral from on there. So make sure you include the dx. I got everything. I'm going to be using u substitution for here. So therefore I have a 2 on the outside. This is going to be the ln of x. And that's going to be interval of 4 to 1. And that's going to be plus a 3. And that's going to be ln of u. And that's going to be on that integral of 4 to 1. Oh, wait. Oh, dang it. Where am I writing this? Yeah. I have too many parentheses going on there. ln there on the integration of 4 to 1. Right that. Okay. So now we've integrated. Now what we need to do is go ahead and identify this definite integral on this on the limit, the lower limit and the upper limit. So basically what we're simply going to do is just plug in these values in for there and subtract the upper limit from the lower limit. So now I'm going to have a 2 times a ln of 4 minus a ln of 1 plus a 3 times a ln of 4. Oops, don't forget, it's not 4, right? It's 4 plus 2, because remember, you're plugging 4 into u. So when you plug it into u, it's actually x plus 2, so it's going to be a 6. I almost forgot myself. So that's going to be ln of 6 minus a ln of 1 plus 2 is a 3. Okay, so now what do you recognize is I can go ahead and use some logarithmic properties, right? Remember, when you have the ln subtracted by another ln, you can just divide your arguments. So in this case, I can simplify this to a ln of 4 divided by 1 plus here a 3 times a ln of 6 over 3. Now this will be simplified to a 4. So you have a 4 ln of 4 plus a 3, and 6 divided by 3 is just going to 2. So 3 ln of 2. Now a lot of students will say, all right, well, we're kind of done here, right? We're good. But because you can't really add these, because you have to have the argument be exactly the same. But since this is a 4 and this is a 2, a lot of students might say, maybe oh yes, I did forgot the second integral d for the second integral. Thank you so much. Dang it, Daref. I knew I was going to make a mistake. Good catch. Yes. Thank you. T2 times ln of 4. But here I can rewrite the 4 as squared. So this would be a 2 ln of 2 squared plus a 3 ln of 2. And then using the properties of logarithms, I can multiply that across or multiply that to the front. So therefore it's a 4 ln of 2 plus a 3 ln of 2. 4 plus 3 is going to be a 7 ln of 2.